Open your bathroom cabinet right now and count the bottles. Shower spray, tile cleaner, mold remover, grout whitener. 4 products, sometimes 5, each one promising to destroy the black creeping stains that keep coming back no matter what you do. Now here's the part that most people never question. What if every single one of those bottles was designed to fail? Not dramatically, not obviously, just enough to make sure you buy another bottle next month. A structural engineer named Marcus Webb discovered something strange while renovating a 1920s farmhouse in rural Vermont. Behind the walls, he found timber framing that had been coated in a simple whitish paste, crude, almost primitive looking. The wood around it was completely clean, no rot, no mold, no discoloration. The surrounding untreated wood had been slowly consumed by moisture and fungal growth for decades. The treated beams looked almost new. Webb sent samples to a materials lab. The results came back pointing to a combination of 2 inexpensive mineral compounds, the kind you can find at any hardware store for under $3 combined. He assumed this was well documented. Surely modern cleaning science had improved on it. It hadn't. In fact, the compounds had largely disappeared from commercial cleaning formulations sometime in the mid-20th century, quietly replaced by synthetic biocides and chemical surfactants that work fast, smell strong, and wear off in weeks. The question is not just what this mixture is. The deeper question is why something this effective is almost never talked about anymore. The story starts long before Marcus Webb, long before modern chemistry, and long before the concept of a cleaning product aisle ever existed. Ancient builders understood something that contemporary construction largely abandoned: that certain minerals found in the earth have a natural and permanent hostility toward fungal life. In Egypt, structures that survived thousands of years were often coated with lime-based washes. Roman engineers applied slaked lime to interior walls not just for aesthetics, but because experience had taught them that mold simply did not grow on properly treated lime surfaces. They did not have microscopes, they did not understand spores or mycelium, but they observed over generations that lime-treated walls stayed clean, while untreated stone became dark and degraded. Medieval European builders continued this tradition. Whitewashing with lime was a standard practice in homes, cellars, and barns throughout the continent. Farmers applied it to the interior walls of animal enclosures to suppress disease. Hospitals in the 19th century used it on walls and floors as a basic sanitation measure. Then the second compound entered the picture. Borax, a naturally occurring mineral salt mined from dry lake beds, had been used in cleaning and preservation as far back as ancient Persia and China. By the early 1900s, it had become a household staple in North America. Companies like 20 Mule Team marketed it as a universal cleaner, deodorizer, and preservative. It appeared in laundry formulas, dishwashing powders, and wood treatments. For a period in the early 20th century, combinations of lime and borax were commonly used in damp cellars, root storage rooms, and early food processing facilities, precisely because they created an environment where mold could not establish itself. Then came the post-war chemical revolution: petroleum-derived surfactants, synthetic biocides, chlorine-based sprays, products that worked instantly and dramatically, and wore off almost as quickly. The market shifted toward fast results packaged in spray bottles, and the slow, permanent, mineral-based approach quietly faded from mainstream use. It was not banned. It was not disproven. It was simply made commercially inconvenient. To understand why this combination works so well, you need to understand what mold actually is and what conditions allow it to survive. Mold is not a single organism. It is a classification of multicellular fungi that reproduce through microscopic spores. Those spores are essentially everywhere: in outdoor air, indoor dust, in the fibers of your clothing. They are not a contamination problem. They are a permanent environmental reality. What turns dormant spores into visible mold colonies is a combination of 3 things: moisture, an organic food source like wood or drywall, and a surface pH that allows biological activity. Most molds thrive in slightly acidic to neutral pH environments, roughly between 4 and 7 on the pH scale. This is the natural range of most building materials: untreated wood, painted drywall, and grout. This is where lime becomes extraordinary. When hydrated lime, calcium hydroxide, is mixed with water and applied to a surface, it raises the local pH dramatically, often to between 11 and 12. At that alkalinity level, the enzymatic processes that allow mold to grow, feed, and reproduce simply cannot function. Cell membranes break down. The biological machinery of fungal life shuts off. This is not a toxic chemical attack. It is a fundamental disruption of the environmental conditions mold requires to exist. But lime alone has a limitation. As it dries and reacts with carbon dioxide in the air, it gradually carbonates, converting back into calcium carbonate, which is essentially mild limestone. Over weeks and months, the surface pH slowly drifts back down toward neutral. The protective window closes. This is where borax completes the system. Borax, sodium tetraborate, creates a secondary layer of protection through a different mechanism. It interferes directly with the cellular metabolism of fungal organisms, disrupting their ability to convert nutrients into energy. It also maintains a moderately alkaline surface environment on its own, around pH 9 to 10, which extends the hostile conditions for mold even as the lime's peak alkalinity fades. Together, they address mold through two separate biological pathways: environmental disruption and metabolic interference, which is precisely why the combination is so difficult for mold to overcome. Walk into any home improvement store today and look at what the professional-grade mold treatments actually contain. The active ingredients in most commercial mold sprays are sodium hypochlorite, which is bleach, or quaternary ammonium compounds, a family of synthetic biocides used in everything from disinfectant wipes to swimming pool treatments. Some premium products use hydrogen peroxide or tea tree oil-based formulations. These products are effective. That part is not in dispute, but their effectiveness is almost entirely surface level and time limited. Bleach, for example, is exceptional at eliminating visible mold staining and killing active surface growth. Pour it on black mold and the dark color disappears within minutes, but bleach is water-soluble and does not penetrate porous materials like grout, wood, or drywall. The water in the bleach solution actually carries moisture deeper into the material, and mold lives in that deeper zone. The surface looks clean. The underlying colony is undisturbed. Most commercial mold sprays are also formulated for single application convenience. They are not designed to create lasting protective conditions. A clean surface that dries back to neutral pH is a surface ready for recolonization within days, especially in bathrooms, basements, or any area with recurring moisture. This is not a conspiracy. This is product design shaped by market expectations. Consumers expect fast, visible results. Spray bottles produce fast, visible results. The fact that the problem returns in a few weeks is attributed to the environment rather than to the product's limitations. The lime and borax approach operates on a completely different philosophy. The goal is not to kill today's mold. The goal is to change the surface conditions so permanently that mold cannot return. On non-porous surfaces like sealed tiles, the difference in short-term effectiveness is minimal. Both approaches kill surface mold. But on porous materials, grout, raw concrete, unpainted plaster, timber, the mineral approach penetrates, alters the substrate chemistry, and continues working long after it dries. A professional restoration contractor working on historic masonry buildings will often apply lime-based consolidants and mineral washes precisely because modern chemical sprays cannot provide the kind of lasting protection that stone and brick structures require. The knowledge never entirely disappeared. It just moved out of the consumer market and into specialized trades. The practical application is simpler than the science suggests. For a basic surface treatment, food-grade or technical-grade borax is dissolved in warm water, roughly 1 cup per gallon, until fully dissolved. Hydrated lime can be incorporated in smaller proportions for surfaces where the more aggressive alkalinity is appropriate, such as raw concrete floors, basement walls, or exterior-facing masonry. On bathroom grout, which is one of the most persistently problematic surfaces in any home, a solution of warm water, borax, and a small addition of white vinegar creates a working cleaning application. Apply it, let it dwell for 10 to 15 minutes, scrub, and rinse. The borax leaves a light residual coating in the porous surface of the grout that continues to inhibit regrowth. For prevention rather than treatment, which is always the more effective strategy, borax solution applied to surfaces after cleaning and allowed to dry without rinsing leaves a lasting inhibitory layer. It does not leave a visible residue on most surfaces once dry. It does not smell. It does not require protective gloves in normal household concentrations. In basements and crawl spaces, painting raw concrete or block walls with a lime wash, slaked lime mixed to a thin paint-like consistency, creates lasting alkaline protection that can survive years of moisture cycling. Many historic European buildings with centuries-old lime-treated cellars show dramatically less fungal growth than modern equivalents. Exterior wood surfaces in shaded, high-moisture environments can be treated with borax solutions before painting or staining. The borax penetrates the wood fibers and provides lasting fungal resistance that most synthetic primers do not replicate. This technique is standard practice in timber frame restoration and is widely used in Scandinavian building traditions where damp climates make wood rot a constant challenge. For households with recurring mold problems in window frames, around bathtubs, or in laundry rooms, the approach is to treat the problem as a surface chemistry issue rather than a cleaning issue. Clean the mold, restore the surface, then modify the surface conditions, so recolonization becomes difficult. Borax spray applied weekly during the first month after treatment, then monthly thereafter, maintains the protective chemistry without any significant effort. At the beginning of this video, we asked why something so effective seems to have disappeared from mainstream cleaning products. The answer is not dramatic. There is no single decision, no documented suppression, no formal prohibition in most countries. Borax, in fact, carries some regulatory restrictions in the European Union regarding certain industrial applications, not because it is dangerous in household concentrations, but because of concerns about reproductive toxicity at high occupational exposures. This nuance sometimes gets simplified into claims that it is universally banned, which is an overstatement. The more accurate story is about market forces and product design philosophy. A mineral compound that costs $3, penetrates surfaces, and keeps working for months is simply not compatible with a retail model built around repeat purchases. The commercial cleaning industry is not organized around permanent solutions. It is organized around consistent consumer need. What Marcus Webb found behind those Vermont farmhouse walls was not a secret. It was knowledge that was once common, proven across centuries of practical building and sanitation, and eventually sidelined by a system that rewards speed and packaging over durability and chemistry. The interesting part is that none of it requires special expertise. The materials are available. The science is well documented. The application is straightforward. The gap is simply awareness, which is exactly what this video exists to close. Mold is not an enemy you fight month after month with a spray bottle. It is a biological process that responds to environmental conditions. Change the conditions, and the fight ends. If you find value in practical knowledge that gets overlooked in mainstream conversations, consider subscribing. There is a great deal more of it waiting to be rediscovered.